In this video, we're going to discuss multicolinearity. Multicolinearity is an important problem, and to set it up, we're going to look at our longitudinal vision data set split by ethnicity. We're first going to do a regression, a linear regression with refractive error. We're going to look at refractive error just single, looking at vitreous chamber depth. We'll just run that. And we can see our R squared is 34, 16, mostly vitreous chamber depth is highest with Asians and so forth. We have our coefficients. Needless to say, refractive error is important, vitreous chamber depth is important in predicting refractive error. So for example, for each increase, a unit increase in vitreous chamber depth, for each millimeter increase in vitreous chamber depth, we lose a diopter in refractive error. Let's do the same thing. Regression, linear. Let's look at axial length. And same sort of thing, we get R squared is very similar, highly significant. Coefficients, again, for about every millimeter increase in axial length, you lose a diopter in refractive error, refraction. All right, now let's do a multiple regression. Let's regress linear. We have axial length. Let's add, see if we can do better when we add in vitreous chamber depth. Let's do some statistics. Let's do our descriptive and this thing called collinearity diagnostics. And let's see what we have. So our model summary again, and you know, we added two variables. We didn't do much better than with just one. So here we have 0.392, 0.341 with chamber depth, 0.390 with axial length. We're not getting much by putting in two variables. So if we look at our descriptive statistics, our correlations, what do we notice? We notice that refractive error is correlated with mean axial length, minus 0.62, vitreous chamber depth, 5.84. But here we go, vitreous chamber depth is correlated 0.957 with mean axial length. They're almost the same variable. And so we're not gaining anything by adding this other variable. And let's look at our coefficients. So in this case, when we have, for the Asians, when we have mean axial length, we have minus 1 diopter lost and plus 2.2. So for every millimeter increase in chamber depth, you go in the opposite direction for refractive error. So when you correlate variables, unpredictable things happen. You would be remiss in coming to the conclusion that vitreous chamber depth reduces refractive error in people, and so, or makes them more hyperopic. that would just not be the correct conclusion. You can see that's the way in each of these cases. That's because you get unpredictable results when you have positive correlations among the independent variables, or when you have any correlation, positive or negative, among the independent variables. So that's multicolinearity, that's the problem. When we look at the diagnostics, here we see for each variable, each coefficient, we have tolerance and variance inflation factor, VIF. And tolerance is just 1 over VIF. And the variance inflation factor is a measure of how much one variable is related to all the other variables in the model. In this case, there's only one other variable. So these are reciprocal. Both are 11.94. If we had 3 variables, they'd all be different. So numbers greater than 10 are bad. So if your variance inflation factor is greater than 10, you have too much multicolinearity, and you should do something about it. Drop out a variable or something like that. Down here, we also have some, this one is a little more complicated, but and sometimes over zealous in showing the problems. This number is greater than 30, then you have too much multicolinearity. But I've seen problems where it's over 30, but it's not too bad. So that's multicolinearity. When you run your regression, you should, in multiple regression, you should add the collinearity statistics and check for these numbers greater than 10. You should plot your data. You should do descriptives and look at the correlations, the intercorrelations in your model, and do the descriptives up here to calculate the standard deviation so that you can trim your outliers. That's it.